Hi, how are you? All right, can you hear me? Oh, hi. Okay, great. We're doing this untested, so we'll see how it goes. Didn't test the slides, just tested the mic, but we're rolling with it. How are you feeling? Okay. I'm really glad that Jeremy kicked this off because that talk is such a great way to roll into Houdini, and I can't wait to get started talking to you about this topic. Before I dive too much into it, I'd love to hear a little bit about who you are. Who here writes a lot of CSS code? Wow, that's like everyone raised their hand. I like to hear that. Who here would call themselves a front-end developer? Do we have any back-end developers here, or full stack? Okay, so it's mostly a front-end crowd. That's good to hear too. I think that you'll be interested to hear about this topic and sort of what's going on. So to get into it, before we go too far, a little bit about myself. I work at Google on material design. I also have an Instagram where I create little technical illustrations and mnemonic devices for web development concepts called DevDoodles. That's my podcast, Toolsday, that was just mentioned. You can go to toolsday.io. And then I also have a YouTube channel where I'm starting to do more content on there too. So today, hopefully, you will learn about CSS, how it works today, limitations, and things that are really exciting that we can do now. What is Houdini? We'll talk about the different Houdini APIs. We'll talk about how to use Houdini today. And then I'll go through a little live demo and get a little bit extra. So writing CSS 15 years ago was definitely much more challenging than it is today because the web has allotted us a lot more capabilities. I love this little meme. When I was a pup, I had one toy and it was a stick. I love dogs. I don't know if anybody here used Dreamweaver. Who used Dreamweaver? Yeah. So you had like 4 layouts you could pick from, and they were fluid, they were responsive, and there was a lot that you could build from here. But again, it was really limited compared to what we have today. Now we have things like grid that you'll hear all about later with new unit types. I love using emoji in grid because it's like this great like single unit way to describe what you're looking at with grid templates. And it's just so magical and just instantly works. Like now the sidebar is going all the way to the top, running along this example. I can make it run all the way to the bottom. You can set all the sizes here throughout the grid. You can change these units again. Like it just works so fast. And so if you're interested in that, definitely stick around for the talk about grid later. But we have these layout mechanisms that we've never had before, and this is pretty recent too. We also have CSS custom properties. Who here has used CSS custom properties? Okay, not enough of you. This is such a great tool that we have here. And so CSS custom properties are basically like variables in the way that we've seen them used today. So right here, I have this primary color, hot pink, and this secondary color on the background. I'm using this wheat color, just using some named color values. And so here I can then specify the background color to be the variable -- background that I specified in the root here. And the header color is this primary color, which is hot pink. So that's all great and good. We see it here. I can update these values. I can change this to red if I wanted to, and it all updates. But you can also update this in JavaScript because with CSS custom properties, unlike a Sass variable, it is dynamic. This is something that the user has a lot of control over. So here I have a function called change background where I'm basically setting the property background to a certain color. So I can just write change background to, let's say, yellow. And then when I hit enter and run, it changes to yellow. And it's all really dynamic. So we can take that a step further now, and we can apply this to the mouse moves just to show you how dynamic and how quickly changing this really is. So if I run this with on mouse move, we're looking for the location of the mouse from left to right, X and Y, and we're adjusting the R value in the RGB. So that's where we're setting the R value is going to be e.clientX, and that's this location on the mouse. So we can take that even a step further and have it track X and Y values. So we can get the X value, the Y value, log them, and then change the background of the red and green values. So now we have like this rainbow effect in the browser that's happening really quickly, really smoothly, and we're doing all of this by writing this logic in JavaScript, and we're applying the styles in CSS. So this hasn't changed. This is still the background of our background. We're just changing what our background is. So it's really cool to see that is now something that's possible. But don't get too excited, because there's still a lot that we can't do in CSS. Form styling is such a burden in CSS. Styling drop-down menus is still so hard, and it's so frustrating. You can't really do a ton with form styling. I Googled, okay, how to custom style form, and W3 Schools is a website that has basics on how to use the web, and so I thought, okay, this is what I want. I want this custom drop-down. So I started looking at how they did this. This is their example to the world. You have to apply your HTML. That makes sense. Then you have to apply your CSS. Okay, that's a little heavy, but that makes sense. But then you have to apply all this JavaScript. And this is where I'm just like, ugh. Not really, style. That's not style. I don't like writing JavaScript to apply styles. It's not semantic that way. CSS gradients are super, super cool. You can create entire backgrounds with CSS gradients, and they're really dynamic. You can have a whole list of gradients and apply them on top of each other. For example, here I have a radial gradient that I can just remove and apply, and this is the circle at 50% 0 at the top there. I'm offsetting it away from here 40%. I can make it 0, and then it'll go right in the center, a little closer into here. So really, there's so much that you can do and just change these gradients and make them really dynamic, change their colors. It starts with just going from navy to red, and then I'm building and building and building and mixing with transparent colors. So this is really cool. You can do this on the web. I love doing this. I love integrating this with filters and seeing how it affects images and backgrounds, things like that. But things that you can't do on the web right now are conic gradients. So conic gradients were really pushed for by Leah Vrew, who's also speaking later today. And they basically let you start at a single point and go around in a circle and reach back to that point. And there's a lot of great examples that she shows about where this could be used with pie charts and other things like that. And so I'm in Chrome Canary right now, and you can see that it's working fine in Chrome Canary. But when you look at the usage across browsers, we now have support in Safari, but it's pretty rough still. So you can't really use conic gradients on the web either. Animated gradients are another thing that doesn't really exist in CSS of today. And so what I have here is I have an example div that's going from red to deep pink, and I'm changing it to go to blue when you hover. So instead of red to deep pink, it's going to blue to deep pink. But you can't have that transition nicely, even though I have a transition duration property here, because the browser doesn't understand that this is a color value that can be interpolated. So it's another thing that you can't really do. Custom borders is a thing that you can sort of do, because there are a lot of options, and border image is really cool, and you can take images and borders and slice them and apply them on your divs, on your examples here, on any element. But when you really want to have it non-standard, you just have a couple of options. You have this control, and if you try to go a little bit outside the box there, you start to run into issues really fast. So can't really do that on the web. Corner shape is another thing that Leah Vrew was really instrumental in trying to push back in 2013, but not something that we have on the web today. It would be so cool if we could have different types of corners. And yes, you could sort of do this with border image, but border image doesn't create a mask on that element itself. So if you have any sort of background on there, it'll go outside of that border to fit the shape of that rectangular div. So still not really something we can do. It never got implemented, and that makes me sad, because I'm now running into all these use cases where having a border shape would be great. But that's where Houdini comes in, and that's why I'm so excited about this technology and what it means for the web. So if you're wondering, what is Houdini? Houdini basically allows us to tell the browser how we want it to understand our CSS. It's a low-level API for CSS that puts the control into the hands of the developers. And a lot of you, in fact, almost all of you raised your hand when I asked you if you wrote CSS. So now you can tell the browser how you want it to understand the CSS that you are writing. And that's exciting. It's a fun time. So what does that mean? Right now, if you want to change the style of an element in a way that it doesn't exist in the CSS spec, in the properties that we currently have allotted, you have to write a JavaScript polyfill. So you have to wait for the page to read the DOM in the CSS Object Model. It'll go through a cascade layout paint composite step to make appear on the screen what we expect to appear on the screen. And then you have to run that polyfill and rewrite those steps. So you have to go from the start. And depending on where that JavaScript polyfill, depending on the properties that you're adjusting, you'll have to either repaint it, recompose it. Maybe you have to do a layout change and then go through those steps again. But with Houdini, what we can do is tell the browser how we want it to read CSS from the start, so it only has to go through that process one time. Because at the beginning, at that style step, where we're expecting to apply those styles, that's where we're telling the browser what we want it to see. So even though big browsers might be slower to implement things, you could be like this little dog, this little pupper zooming along, and getting it done. And that's sort of what Houdini allows you to do. There's a really great website called ishoudinireadyyet.com, and this shows all of the different APIs in Houdini and their current support level. So you can see it's still a very experimental spec, but I do think that this is what we are going to see as the future: how to write CSS, how to write polyfills for styles, and the browser vendors have all sort of agreed that this is a direction that they're going to push forward with. It's just going to take some time to get there and to implement all these different APIs. And they also all work in a little bit of a different way and handle some various styling tasks. So I'm going to go through those and talk about what they can do for you. So let's start with the Properties and Values API. So I just showed you CSS custom properties, and a lot of people use them now as CSS variables, which is a great way to use them. It's a good replacement for that. But they are so much more than that, because they give us the capabilities of variables and a lot more functionality sort of behind the scenes. The way that you register a custom property is with this syntax, where you write css.register property, you give it a name, a syntax for it to read from, an initial value, and then you can say if it inherits or not from the parent. So here's an example of that. We have a box here. I'm going to go into the CSS here. I have, like in my previous example, a linear gradient with a color is transitioning from one color to another. And here I'm setting the color to red, so I could set this to yellow or any other color and run it. And you could see that it changes. But when I hover, I'm changing that color to blue. And I'm even putting this in the transition. I'm trying to transition this shade, but it doesn't understand that this is a color value. Now, if I create a new property, let's call it color stop. We can call this anything. We can call this new color. Now we have created a property and given it a syntax to read from. So anytime my browser sees new color, it knows that it is a color value. So it knows that it can interpolate that color value. So now if I update this to new color, I update this value here to new color, and I update here when I'm hovering it to new color. I also want to make sure I'm transitioning this. And I run that, it can know to transition, and it knows to slowly interpolate that value and to go from yellow to blue in a smooth way. So now we've created a custom property that has some sort of syntax, some meaning behind it. The current syntaxes are listed here. This is as of the latest version of this draft, 7th of May. And that's length, number percentage, length percentage, color, image, URL, integer, angle, time, resolution, transform function, and custom indent. So this list will be growing, but this is what you currently can use today. The other really cool thing about custom properties is that they can be used with fallback values. And what I mean by this is I've created two custom properties here. I've registered color primary and color secondary, given it that syntax of color. And I also gave it an initial value of blue, violet, and deep pink. So in my CSS, I haven't specified what these values are, but I can still call them. I can still call color primary. I can still call color secondary. So when I hover, it's going from that deep violet color to this pink color, this magenta color. And so I can update this too. I can go into box and I can update color primary, and I can set this to red. And then if I run that, it'll update because I'm telling it that there's a new value that overrides the default value. But if I don't have a value, then it knows that there's a fallback. The other cool thing about this is you can kind of use it as error handling. Like if I have this value 23, that's like a color, like a random number. That can't be a color value. When I run that, you still see that deep purple, and that's because it falls back. Now with a value, a CSS custom property that I haven't registered, the browser doesn't know this. So if I set this to like a color, and I set this to a color, and have that be 23, it just leaves it white. It leaves it without a value. It doesn't know what it's reading. If I have this to red, again, it can still read that as a color value because I'm setting it. But because we have that condition set, because we have a default, this initial value set, even if I have an incorrect value there, it can still fall back. And we get a value, and that's going to be the color primary. So I think that this is sort of like having typed CSS variables where you're providing a syntax type and you're providing a color default. And it's also great for systems. So if you're building design systems or working in that space where you're trying to grow and scale CSS, this is a great use case for that because you can create rules around your CSS. Okay, so now I'm going to talk about the typed object model, which is the second most supported property right now. And what this is trying to do is improve the performance of our CSS. So right now, the current CSS object model is string-based, and that means that the browser has to go through and read all of that text as strings and then parse it, concatenate it. So this spec introduces a new way to interact with underlying values by representing them as specialized JavaScript objects that could be manipulated and understood more easily and more reliably than that string parsing and concatenation, which the browser does today. So these CSS values become these typed JavaScript objects that have key value pairs that the browser can understand and parse. So instead of going through all of this and sort of reading those as strings and going through that entire process, there's going to be semantic meaning here. So that means better performance. Since we're doing less string parsing, we're doing less reading of these string values and then going through those steps, we can improve the performance. Object lookup is so much faster than having to parse through strings. So you can set and get computed values with attribute style maps. So an example would be element.attributestylemap.set, and then you could set any CSS property there, or get a property from any element on the page. And so to just show an example of that, I have this box here, just giving it a width, height, background color. And in here, I just have it logging computed style map.get height and opacity. And we can even adjust that. So if I wanted to change this opacity, like I showed earlier, you can set this through the attribute style map, and then it'll come out with this new value. But this doesn't really show the entire benefit of using the typed object model. So if I wanted to show you that, I could kind of just make this a little bigger, use my console here in Chrome. And so $0 in the console just selects any element that you have selected on the page. So I'm going to type $0.computed .get, let's just say height. And then here, what's really happening is it's giving you a unit value and a unit and a value, and so this is 200 pixels, but it's a more structured data approach that the browser can then use and make it a little bit faster to read and write CSS for you all. So that's just like a really cool, nice thing to have. That's a Houdini spec. Now I'm going to talk about the paint worklet, which is my favorite aspect of Houdini because there's so much that we can do here, and it's so visual, and it's just really dynamic and a great part of the spec and something that we have available to us in Chrome and Canary and experimental browsers behind flags. So we just learned all about service workers from Jeremy, and that was like I said, great intro to this because as you just learned, there's so many great benefits of using web workers and service workers, like caching things for offline, all those pre-rendering of assets. Also, you can send push notifications, lots of things. And the reason is because that service worker lives in between our network and our website. And we just went through how this works. But this is something important to bring up with the worklets in Houdini, because this is how those worklets work as well. They work like service workers, where they live outside of the main thread of your website. They live between that network and that website layer, which is why when you're using Houdini, you have to make sure that you're either working in localhost or using HTTPS, just like with service workers. So in order to implement a paint API service worker, so a paint worklet, you would write out your worklet in JavaScript. So you could create a class and then register it. So you would write and register this worklet inside the JavaScript. You then would invoke the worklet file in your HTML by using the keyword of add module. So you do css.paintWorklet. That's the type of worklet that we're invoking. And then you would add that module to your code, because again, with these sort of files like service workers and worklets, you have to tell the browser that you want to implement it and tell it to set it. And then in CSS, we can use the worklet by name. So you can use, background paint, and that's the type of worklet, and then name it. Since we give it name fun inside of the register paint function here, then that's what we want to use when we are using it in CSS. So is this kind of like writing JS in CSS? Yes, this is exactly like writing JS in CSS. So here's an example. I just wrote a quick little rainbow ties worklet where I'm just coloring these squares from top to bottom, adjusting the color as I go. And this is just like kind of playing around in Canvas. It's like a very Canvas-like syntax. So at the end of this, I want to register this paint rainbow ties. So I'm going through that, registering paint. Then in my index, I want to make sure to register this module inside of the document there. So css.paintWorklet.add module. And then I'm just linking to that file name. And then in CSS, I can use this as a background. I can use it as anything, really. You can use this as a border image. You could use this as a mask. There's a lot of different ways to use these worklets that you're creating. You basically have a blank canvas to use your creativity to draw something and then to apply that to an element on the page. Here's an example of using conic gradient. So this uses Leah's polyfill that she created for conic gradient. And what we're doing is we are writing this in the worklets. We actually are also using arguments here. So you can accept an argument list so that when you are writing this in CSS, you can specify you want to paint conic gradient and then have this arguments list red, magenta, blue, cyan, lime, yellow. And then here you can keep going. Like if I wanted to circle that back up and end with red, this is all working in the browser today. This works in Chrome. And so that kind of syntax really allows for a lot of adjustment and transformation, because it's basically creating a function with input arguments that you can change and you can apply. And you can create these sort of polyfills, but it renders faster than it would with a JavaScript polyfill, because it's rendering when the CSS is being added to the page, when the browser is applying those styles. So this is a lot like extending the web, extending the current version of the web that we have today. And it becomes relevant for me in my role now, because material design is something that I'm working with, and it's this great design system that's provided to a lot of different teams from Google. And what it allows you to do is create these unique themes by using your own brand and applying the same principles that have a lot of like tested best practices from material. And one of those things is applying theme color and style, and that basically lets you adjust color, typography, and shape of your elements to create things like this. Here's another example of that called Shrine. This is an example app that was created where it uses these angular shapes instead of rounded shapes. But on the web today, as I showed earlier, you can't have these cut corner shapes. You can't have that corner shape. It doesn't exist. And so this part of the spec only works on iOS and Android, and it works as a design spec, but it doesn't work on the web. But that's where Houdini can come in. You can have rounded corners, but you can't have that cut corner. So I was playing around with how we could implement this with each corner having a different radius, with two different styles, outline and fill. And this is just such a work in progress, but it shows how much you could really accomplish by using Houdini inside of these elements. And so I started thinking about how I could best make this work with the material design web components. So this is MDC Web here, and so I have this base material button that whenever you click, you get this response also. Like, that's important, having that interaction, make sure that it stays within that element. And so I started playing with like that notched little example that I had made with the notch on the top left corner. And so I started with a mask, but what happened was you basically can't get all of these lines here to fit within that mask, because you're just saying, I want to mask this shape. And also you lose the shadow. There's a shadow here on this raised button that you're missing because you're masking the shape. And so anything that's outside of that, you lose. So then I started thinking about, okay, maybe I'll apply it as a background here. So I applied it as a background, but then it doesn't work with the outline. So then I applied it as an outline, but then that kind of works here, but then when you click on it, you're still outside of that notch shape when you click. And that's because border image works that way, where you can create a border image, but when you hover or apply a background color to it, you're still going to be in that rectangular shape of that element. So I went through and I applied a lot of these different styles here for the different types of buttons, and I thought, okay, maybe we can make this work. And you can, but it takes a little bit of adjusting. So here what I ended up doing is I recreated all these buttons with the notch style, with that sort of click handler, that effect staying inside the lines of that element. And what I did was I had to then make sure to use the different types that I had used here. So instead of having the fill on everything, I just had the fill on this button right here, and then this button I had to recreate the background so that I could not make it mask, so that I can give it a drop shadow, and I had to do that with a filter so that it wasn't using the shadow where the notch was. And then for this outline button, I had to use the mask and I had to use the outline. So, you know, you can play here, but you can get these effects on the web now that you have in other platforms like iOS and Android by mixing material, mixing things that exist in systems with Houdini. So it's definitely something that we can use like in the intermittent process of building. Layout is another worklet that Houdini allows us to build with. So the Layout API is designed to give web developers the ability to write their own layout algorithms in addition to the native algorithms that user agents ship with today. And what I mean by that is this. Today's layouts are float and block flow. We have flexbox, we have grid. But tomorrow's layouts could be constraint-based. We could be using the web on watches or on our refrigerators. We're already doing that. That already exists. Masonry is a layout example of things that we'll be able to do. Vertical rhythm, where you are able to set a specified line height and have that be uniform throughout. So like, if you're printing a web page out on a piece of lined paper, there's uniformity in where those lines are, instead of just having it kind of be all over the place, which I've done when I was in school and I had to print things out and didn't have any other type of paper. So the way that this works is using these intrinsic sizes and layouts. So you have children and edges and then constraints of that, and you can lay those out. And I think that the best way to sort of talk about this also is with an example. So here is an example of a random layout. I'm just going to open this in a new window to show you. So here's this random layout. And all of these elements are just being placed randomly throughout the page. Again, if I inspect this element, you can see there's different layout fragments, and they all have different offsets and block sizes. So what we're doing is, inside of this worklet file, we are printing out the position. So this is randomly assigning math.random times the fixed inline size and block size to the inline offset and block offset of each of these elements. So it creates this randomized layout, and you're returning these child fragments on the page. So every time you run this and refresh this, these divs in that body just look like this. You have a main context, and then you just have A, B, C, D, and divs. But because we're applying this worklet inside of our file here, when we apply it to the CSS, you're just displaying random layout on all of the children inside of that main parent. You get this randomized layout all throughout. So just some really interesting different things that you can do with that. Masonry is another example where you can adjust the padding and columns. So I can change this to be like 4 columns if I wanted, and more padding. And so this adjusts, and what Masonry does is you re-lay out these elements to best fit the top left corner here. So that element moved over to have it adjust to the top left. And it's just another common web pattern that we see that we can now have the browser understand from the start by using Houdini and having it be applied through CSS. So I'm going to talk about the animation worklet briefly because it's definitely a work in progress, and this one only works in Canary right now. But it's a new primitive for creating scroll-linked and other high-performance procedural animations on the web. So right now, the Web Animation API, which also is pretty new, gives us an animation timeline, so you can go from start to finish, reverse, pinpoint any point in that timeline. There's document and effect timing because of that timeline, and a keyframe model, which if anyone has played with Flash, you're familiar with how keyframes work. We now have a keyframe model on the web. The animation worklet gives us scroll-linked animations, so as you scroll, you can apply animations that way from the browser, and also dedicated threads that run parallel to the main thread of your browser. And that's sort of the whole idea of having these as separate worklets, where you can pull them and update them when you need them, but they don't live sort of in that thread, clogging up your other JavaScript, your other styling, things like that. So here's an example from Surma where, again, like I said, this is such a work in progress that it sometimes works. So in theory, if you can imagine, this little icon moves to the top here like you would have in CSS. This is what happens when you try demos. Yep. Okay, there it goes. Sometimes it works, sometimes it doesn't. Like I said, this is all like very experimental web tech. So then again, as you scroll, that sort of moves up to the top, and that's done with the animation worklet. Another demo here is this spring box. Let's see if refresh fixes that. So what this is supposed to do is these boxes kind of spring up to the top and then come out. And again, this sometimes works, sometimes doesn't. I'm trying to figure out why the rules are for that. But for now, believe me. Oh, there we go. Yeah, see, now it's working. I needed a moment to register, probably. So if you want to see that yourself, you can go to this URL, googlechrome.labs.github.io. It has a lot of different Houdini samples. And you can start to sort of like play around with them yourself there. So note that today the animation API will only animate fast properties like opacity and transform, and only items that can be composited. And this is a good rule anyway. Opacity and transform really give you the best bang for your buck in terms of performance when you use transitions or animations on the web anyway. So that's just a rule that you should all live by if you are adjusting things on the web. So now I want to make some magic, and hopefully this will work out. This will be a little bit of a live demo. Again, this is experimental, as you all saw, so wish me luck here. In order to have this work in your browser, you can go to chrome://flag/enable experimental web platform features if you're using Chrome, and that's where you can enable some of these features. Other caveats, as I mentioned before, must be using HTTPS or localhost because the Paint API is a worklet. And also if you have issues with refreshing it, like with the page refreshing, try disabling browser cache. So you can go into your JavaScript DevTools and just disable browser cache when JavaScript DevTools are open. And that's what I have found to help work with me. You can apply checks in JavaScript and CSS. In JavaScript, you could look for if paint worklet in CSS. And in CSS, you could use add supports, which is pretty well supported except for in IE 11, so just keep that in mind. So you can use for at supports background paint something, and then if it supports that line of CSS, then it will read whatever's inside those curly braces. So, all right, let's start with Canvas. I'm going to open in a new tab here. This doc. Okay, so I have this starter here, and I will try to zoom in as much as I can. So right now we have this little sparkle. Can you all read that? It's pretty big on that screen. Yeah? Can you read that? All right, in the back, we're good? Cool, I got thumbs up. So basically what we're doing here is we're taking a canvas and we're creating a single sparkle on this page. I want to end up making sparkle text that can cover any element. So here what we're basically applying is just some size to this canvas, and then I'm going through and I'm getting the width and height of it. I'm setting a min and max height for every single sparkle, a min and max width for every sparkle, and also a min and max weight. I'm applying this yellow color, and I'm going and getting a random size between the height, width, and the length of it. So everything I've set before, I've set parameters. Now we're getting a random number within those parameters, and also a random position that's within my border of the canvas. So then we're going to set the color and weight of that sparkle and start to paint it. So I'm painting it from top to bottom, left to right. So that's how we've created the one single sparkle. So if we wanted to create multiple sparkles, then we have to set a value here. So if I wanted to set sparkles to be 30, that's going to be the number of sparkles that we are going to be including. So now I'm going to take all of this stuff in here that we're using to calculate the sparkle and just remove it, and then write a simple for loop. So for let I equals 0, I is less than or equal sparkles, and then I plus plus. I want to make sure that that's an equals. Then I'm going to paste this back in, and now I have 30 sparkles. So I have whatever number of sparkles I've set. So next, I want to have the color be applied, not just yellow every time, but calculate an HSL value. So I've set that up here where I'm applying a hue value between 40 and 60, so it's pretty specific there, a saturation that's pretty saturated, and then a lightness value from 50 to 100. So there is more variance in the lightness. And then I'm just going to be using this template string to create a new color value of HSL, hue, saturation, lightness. And so every time you refresh this, you're going to get a new little set of sparkles. So if I was to adjust that and it would refresh, then you'll have new sparkle values. So there's the new sparkles. And this is all well and good, but if we wanted to move this into a worklet, we're not going to be using canvas. So I'm just going to remove this canvas. I'm going to change this to a header. I'm going to call this, I'm just going to say hello world there. I'm going to remove this canvas. I'm going to change that to just be our H1. I need to give this a color, so let me just make it white so you can see it against that background. I'm going to give it a display of inline blocks that when we do apply this, it's not going to stretch throughout the entire page. And I think that's all that we have to do for now. But we also have to remove canvas from our JavaScript. So here we have this sort of canvas and context. We're not going to need that. I'm going to delete that. This also I can delete because we no longer have to set those. And then I'm going to convert this into something that we can use for our paint worklet. So I'm just going to also cut all of this out since I'm going to be putting this inside of our worklet. I'm going to call class sparkles, and then inside of here I'm going to set paint, and I'm going to get the context and size because we need to still get the context and size from our element. And then inside of that I'm going to paste this. So now we have all of that color and styling, everything inside of this class. And I also have to adjust this so it's pulling from size and width and height that we're setting up in here, so inside that paint. And then I have to register it. So at the end of this I have to register paint, and then I'm going to call this sparkles, and then I'm going to call this sparkles. So I'm using this class that we've just created, and I'm giving it a name. That name is lowercase sparkles. So once we've done this, we can then add this to our HTML using add module. And so the way that you do this in CodePen is by using this pen ID. It's kind of like a little hack around CodePen. So I'm going to write a script here, and then CSS is where we are applying this. So CSS is the interface.paint worklet.add module, and then I'm going to do /una/pen, and then I'm going to put in this pen ID.js. and then save that. And now we have to apply this to our CSS. So we have to do background paint sparkles, and if this worked out, fingers crossed, then the sparkles will appear.
In your HTML, there's the quote and the parentheses is wrong after add module.
Okay, after add module. Oh, okay. This is why the front of the room is my code checker, my linter. There we go. So now we have sparkles on the HTML. So this is how you transform from a canvas into a paint worklet. You can do more with this. You can make this animated, so I can add keyframes. So in my keyframes, let's call this sparkle. I can go from and to, And so here, I'm going to improve this in a minute, but I can just, set background to paint sparkles and then apply that here. So I could set the animation to sparkle, 0.5 seconds, infinite linear, and then that should animate. So that animates, and you have your sparkles moving. It worked. So we can do it this way, but we can also do this a few different ways. I'm going to go back into my presentation. And so one way that I saw that I thought was really interesting, would not necessarily recommend this, but this is a technique from IMVDO who creates CSS-Houdini.rocks. He created this worklet where you can basically read any content of a custom property and then evaluate it. That's what this whole thing is doing. It's just evaluating that. So you could theoretically write this inside of your CSS completely, where you have it all as a variable called background canvas, and then we're applying background paint, background canvas with all that logic inside of CSS. And this is kind of like a little like mind trickery. I thought it was really, really cool and interesting though, so I wanted to include that. But caveats to that approach are that you have to make sure you have all your semicolons there because you will run into issues. And also, all the variables must be there at instantiation. It's not dynamic, so you have to make sure that every time you use that sparkles, you have it applied in that element, like it's all encapsulated. So we can actually reorganize this and make it a little bit better with custom properties. So what I'm going to do now is I'm going to go into my JavaScript and I'm going to pull in custom properties. But before we do that, I have to actually write them in CSS. So maybe we want to have the sparkle number controlled in our CSS here alongside with the rest of our code. So I could set a variable called sparkle number to 30, but it doesn't know what to do with that right now. So I'll go into our class here and I will create this little method where I'm getting those input properties. So input properties. And then here I'm going to want to return and sparkle num dash dash sparkle num is the input property that we want to return. So then we also want to pull properties in here. And instead of setting this specifically to 30, we want to do properties.get, and then here sparkle num. So this would be reading from here. And so if we set this to 100 or something big and give that a second and refresh. Okay, so it's painting sparkles. Static properties. This theoretically should work, but again, this is what happens when you do live demos. So in case that messed up, I have an example here where I have it all set up with the input properties. So in JavaScript, you're getting the input properties here inside this register paint, and then you could set it from CSS to be using those input properties so that when you're applying this inside of your animation, instead of setting background, you can just change the number of sparkles each time, and then you're using the custom properties to be applying the changes. And every time you're changing the layout of this, it will repaint. So that's why even without this animation, as you stretch and move and change it, it will readjust the styling and will repaint on the page. So that kind of brings me to this little library that I created that makes your sites a little bit more extra. And it's definitely a work in progress, but it's called extra.css. And this allows you to create a few different effects. Again, when you resize your browser, you will see all of these changes propagate every single time. So if you're using randomization, you will see that adjusting every time. And it's because your layout is changing and then it's going through that paint process. So what this super underline does is it allows for you to set the underline spread, the difference between where those values are applying in that underline, the width, the number and color of the underlines underneath that image. And then in your CSS here, I have it all set up so that you can change all these values inside of your CSS. You can change the weight, you can change the color, you can change the spread and make it wider apart. The next one is the scalloped border, which I used to love drawing like little scalloped borders around my folders and notebooks and stuff. So this gives you the ability to do that. So again, I can change the radius of this to be bigger. I can make it 10. This is on these little links here. If I wanted to change it on this header here, I could make this maybe 2. I could make it a really small little scallop. It looks almost like there's no scallops. If there's 6, you'll see the small little scallops. I can make this 30. But you can really start to, again, make this dynamic, animated, play with it, have it be whatever you want. Cross out is another example where you can change the spread, the weight of this, all of that stuff. And then you could put it all together in a little aesthetic image where I rewrote lyrics to Thank You Next. But that's my talk for you today. I hope that you learned something. I hope that you're excited about what the future has to offer us for CSS. And I hope that you give this technique a try. Thank you.
Wow, that was amazing. I think I've learned a huge amount there about incredible
Future is
Houdini.
bright.
The future. Yeah, we're in the future now. We've got time for one very quick question, I think. And the top one we've got is, how does Paint fall back on non-compatible browsers, and is it a performance nightmare?
Well, in terms of performance, the theory is that it's more performant on browsers that do support it. And that is because it's a separate thread and because it is working in the browser before we're painting the rest of the page. But in terms of fallback support, as you saw, when I tried to scroll with the animation worklet, you didn't see that bounce up. So it remained fixed. It is definitely up to you to have fallbacks that look decent. Like the sparkles demo just won't work. You won't see anything. You won't have that extra effect. So the best way to use this now is definitely experimental or in progressively enhanced ways where you are checking for support of CSS and NJS, and you're only applying it as sort of extra little illustrative pieces on the page. Or make sure there's a fallback like with the animation examples.
Fantastic. Progressive enhancement. That was amazing. Let's have another big round of applause.
Thank
Come on.
you.
Woo!